In this video, we will be discussing about significant figures, its applications, its uses, and also its rules, how to count this number of significant digits in a given number. But before going with significant figures, let us actually understand two important parts of any given number. So consider this number 592.671. Now what I'm going to explain here is when any measurement is given to you, there's one part of the measurement that you can really trust to 100%, but there is also one part that you cannot actually trust. And that part or that digit is the rightmost digit of a given measurement. So imagine if you have a measurement of 592.671, let us say 592.671 grams of something. So a person weighs this in the weighing machine and he gives you this measurement. He says that, sir, this 592.671 grams of gold is available. So do you really trust the last digit or not is the question here. Now here we will have to know some facts. There are many devices which measure the weight, and not all devices are perfectly accurate, and we cannot trust some part of it. And the part that you cannot trust is the rightmost digit. This digit is called as uncertain digit. The rest other digits of a given number are known as certain digits. Now why is this a uncertain digit? The reason is you do not know if this digit was the last digit of the measurement. It is possible that there was some other digit here and the person actually rounded off that because he didn't want it to have too many decimal places. It is possible that this was actually a 0 and there were digits such as 6 or 7 or 8 or 9 and he actually rounded it off to 1. Or it is also possible that the number itself, this 1, the second number was something like 0.6711121314. So you cannot really trust the last digit because you do not know if that is the accurate one or it has been simply rounded off. So this last digit, we always call it as the uncertain digit. Now we have to also leave this digit because of some other reasons. Now consider you were calculating your weight and your weight was turned out to be 67.426 kilogram. So when a weighing machine, consider you were using a really good weighing machine that shows you up to 3 decimal places. So in this case, do you really consider 0.026, these digits, or since we are talking about the last digit, let's say this. Do you consider 0.006? Now when you actually analyze this number, this 0.006 is nothing but 6 grams. So do you at any time express your weight in terms of grams? No, we don't. The reason being this 6 grams is not at all certain. It is not fixed. It can be the weight of your clothes, it can be the weight of your hair that later you might cut, or it might be the weight of something else. So you never trust it in grams. So these digits are uncertain. So most of the time we express our weight in just up to 1 decimal point or maximum up to 2 decimal. We never go up till grams. This is the reason we divide the numbers into certain and uncertain digits so that we can make our measurements more reliable. So now let us see what significant figures are. The simple definition for significant figures is the number of digits in a given measurement that you can trust. So significant figures are nothing but the number of digits in a given measurement or in a given number that you can trust. Now significant figures, the definition, these all might sound very naive at first, but if you consider some large organizations such as banks or petrochemical industries, these significant figures, the knowledge of these significant figures becomes very crucial. Now consider a bank which has around 1 million customers, and each customer has an FD or savings bank account. So when people invest their money in savings bank account or fixed deposit accounts, the bank provides them with certain amount of fixed interest rate. So if let us say that this particular X bank is providing its customer for a fixed deposit account with around 6.5%. Now 6.5% is what the bank will provide. Now imagine if it was not 6.5%, it was 6.51%. Now 6.51% is a total increase of 0.01% for every single customer in 1 million of customers. So actually the bank, just by providing 0.01% additional rate of interest to its customers, will go into huge loss. Although this might not make any much difference to the individual customers themselves, but it will be a huge risk to the bank. The same goes with some industries, if you like petrochemical industries. So significant figures tell you that you do not want to go in loss, but also you do not want to lose your customers because they are unhappy with your rate of interest or with your prices of products. And significant figures actually helps a lot. Now let us begin with the rules with which you can actually count the number of significant figures in a given measurement. So there are typically 3 rules. Now remember, you will be needing these rules only in the beginning. After you solve a couple of 10 to 20 examples, the rules will become your second nature. The first rule is every single non-zero digit is significant. What are non-zero digits are every digit from 1 through 9. All these digits except 0 are all significant. So whenever you encounter any number 1, 2, 3, 4, 5, 6, 7, 8 or 9, you will directly call it as a significant figure. But if you encounter a 0, you will have a different rule. For zeros, we actually divide the cases into 3 types. Now, to understand these 3 cases, let me give you 3 examples. So first example is 8009, 8009. Now the second example is 0.082, and the third example is 82.000. So what I mean to say here is there are 3 different ways in which zeros can occur. Zeros can occur between 2 non-zero digits, and these zeros we can call it as trapped zeros. So these zeros are actually trapped between 2 other non-zero figures, and these are always significant. These zeros are always significant. Now comes the turn of preceding zeros. The preceding zeros, like this one, is a non-significant digit. Preceding zeros are non-significant. The third one is trailing zeros. In trailing zeros, we actually have 2 cases, with decimal point and without decimal point. So we will be going through these 3 rules a bit more in detail with some more examples. So first is trapped significant zeros. If you have a number, for example, 42.03, in this the 0 is trapped between 2 non-zero units, and hence this 0 is significant. And so let us count the total number of significant figures. There are 3 non-zero units, so they are definitely significant, and 1 trapped 0. So even this is significant. So now in this number there are 4 significant figures. Let us take another example. 52.0012. Now again you see here that these two zeros are trapped, are stuck between 2 and 1. These are two non-zero digits, and these are stuck or trapped between these two non-zero digits. Hence these both the digits or zeros are significant, and hence the total number of significant numbers in this measurement is 1, 2, 3, 4. 4 non-zero digits, hence they're 100% significant, and 2 trapped zeros, so even those are significant. So totally there are 6 significant figures. So this is what trapped zeros and their significance means. Now let us take the example of preceding zeros. What I mean by preceding zeros is the zeros that come before a non-zero unit, non-zero digits are known as preceding zeros. Like the example that I have taken here, let's begin with that example itself. So if you have a number 0.082, this zero will not be significant. Now don't get confused with this zero here. These zeros are simply used so that you do not miss the decimal point. Sometimes people do not write this zero, they simply use 0.082, but sometimes the point is too small and hence sometimes missed. Hence we write here a zero. So this has no value at all and it is non-significant. You do not count this zero at all in any cases. So coming back to the preceding zeros, this zero is a preceding zero. This does not have any significance. This just tells us the decimal place of the numbers or digits that follows it. So it just tells that this digit 82 is at the 100th and 1000th place. Digit 8 is at the 100th place and digit 2 is at the 1000th decimal place. It just tells us about that. It does not give us any significance. It does not give us any value. Hence, it is not considered significant. So let us count the total number of significant figures in this. There are 2 non-zero digits, hence it is definitely significant. This is a preceding zero. It is not significant. You do not consider this. And this you do not consider. Even this is a non-significant digit. Hence the total number of significant digits in this number is 2. Now let us take some more examples. 0.0082. I just increased one more zero. So even in these are preceding zeros. These do not have any significance. It just tells us the decimal place of digits 8 and 2. Hence again the total number of significant digits is 2. Another example here I'll give is 0.08005. Now here we see that there are 2 non-zero digits, hence these are definitely significant. There are 2 trapped zeros, hence these are significant too. This zero does not give us any value, it just tells us the decimal places, hence we do not take it into consideration. So total number of significant figures is 1, 2, 3, 4. There are 4 significant digits. Let's take another example. 42.093. Now you might say this zero is after the decimal point and it is before a non-zero digit, hence this is a preceding zero, but that's not the case. You must consider the 2 before the decimal point and this 9. So this zero is actually trapped between 2 non-zero units and hence this is definitely significant. So there are 4 non-zero units, these are significant, and a trapped zero, this is significant. So in total there are 5 significant figures. Now let us come to the last part of the rule, that is the trailing zeros. Now trailing zeros means the zeros coming after the non-zero digits and there will be no non-zero digit after these trailing zeros. These will be the end. So let us take this example itself, 82.000. Now there are 2 cases here, that is with decimal and without decimal. Let us first begin with decimal. So you see there is a decimal point here. This is what means that the trailing zero is with decimal. Whenever there is a decimal point, the trailing zeros are always significant. Whenever there is a decimal point, they are significant. If it was 82,000, these zeros are not significant. Only if there is a decimal point, it is significant. If there is no decimal point, it is not significant. Not significant. Now there can be another situation. The same thing, 82,000 can be written with a decimal point at the end. So whenever there is decimal point, these zeros, the trailing zeros, are definitely significant. So in this case, there were total of 1, 2, 3, 4, 5 significant figures. In this case, these three will not be significant, hence there are only 2 significant figures. And in this case, since there is a decimal point, the trailing zeros will be considered as significant figures, and there are a total of 5 significant figures again. Let's quickly recap both the rules. The first rule is all non-zero digits are significant. So if you see the digits 1, 2, 3, 4, 5, 6, 7, 8 or 9, you mark it or you count it as one significant digit. Any number, any digit except 0 is definitely significant. Now when it comes to zeros, we will get 3 types of scenarios or cases. The first one is trapped zeros. Trapped zeros are zeros between 2 non-zero digits. So those zeros you count as significant. The second case is preceding zeros. That means zeros before the non-zero digit. These zeros you're not supposed to count as significant. These are definitely non-significant zeros. Now the last case in which zero can occur is in the form of trailing zeros. Trailing zeros are zeros after a non-zero digit. And here you find 2 cases. If the given measurement has a decimal point, then you count the trailing zeros as significant. If the given measurement has no decimal point, then you do not count it as significant.